The Leave Plan of Room specialists has found that using our new 101 billion toy, it will apparently always be before that try changes into a reality. On the remote possibility that it goes as arranged, the outing to Proxima B will take nearly 20 years. So, sensibly, it will be several years earlier before we can interest if there is certain life on that planet. The laid-out sails of whether we are truly alone in this universe go through the James Webb Space Telescope, which has discovered some astoundingly human-like things far away from Earth that lead us closer to the response. Our central goal for life beyond us has been uncontrolled throughout every human action, to such an extent that we have countless media works and speculations concerning this matter. Our wonder about our place and insignificance in the universe has been constant. It is ingrained within us to search for a mate, no matter how fractional or different they might be. We might be getting closer to the answers we truly seek. However, are they truly the answers we want, or are they simply more unsettling? Join us as we break down the latest revelation in the space of frameworks and planets on the journey to possibly discovering something we are not prepared to see. Far-off lights have been found by experts, revealing what could be one of the deepest discoveries in history. The search for artificial light on Proxima B. Back in 2021, when the James Webb Space Telescope, JWST, was scheduled for launch, an intriguing theoretical question was raised about our technological capabilities. The inquiry was whether, in the future, our telescopes could detect artificial light on another planet, for example, Proxima B, the closest exoplanet to Earth. Proxima B, located 4.25 light-years away, was identified as being tidally locked, meaning it has a permanent day side and night side, much like our Moon. A hypothetical technological advancement on Proxima B could involve transferring power from the day side to the night side using photovoltaic cells that generate electricity from starlight. In a paper by Manasvi Lingam, a leading space specialist, it was shown that a large-scale solar panel setup on the day side could potentially be detected by future telescopes. Since JWST is significantly more advanced than previous telescopes, it allows us to expand our search for artificial lights on exoplanets like Proxima B. Now, the fact that the James Webb Space Telescope might have actually detected such lights in 2024 is groundbreaking. If confirmed, this could propel humanity into a new era of discovery, triggering a massive surge in scientific and technological efforts. So, let's dive into the world of exoplanets and explore how this was even possible. Proxima B, the mysterious exoplanet. Since the dawn of written history, humans have pondered the mysteries of the universe. What are we? Where do we come from? Where are we going? These are fundamental, yet extraordinarily difficult, questions that we have sought to answer since we first became self-aware. Despite our technological advancements, are we any closer to finding these answers? If you ask a philosopher, he might say we are still at level 0 in our understanding of ourselves and the universe. However, ask a scientist, and he will eagerly share the latest discoveries about the cosmos, using cutting-edge instruments that most of the general public overlooks. We now have the world at our fingertips, and it's time to push further, to bring the universe within reach. One method for doing this is through scientific and technological advancements. A prime example of this is the James Webb Space Telescope, which has made possible the discovery of potential artificial lights on another planet light-years away. What is Proxima B? The James Webb Space Telescope is the product of decades of human space exploration, created to answer some of our most persistent questions. Are we alone in the universe? Who, or what, is out there? Where do we begin, and where do we end? This infrared space observatory is already searching for these answers, including clues about Proxima B. Proxima Centauri B, or simply Proxima B, is sometimes referred to as Alpha Centauri B. It is a super-Earth exoplanet, meaning it is larger than Earth but lighter than ice giants like Neptune and Uranus. Super-Earths are fascinating because they can be made of gas, rock, or a mix of both. Their sizes vary, ranging from twice Earth's size to several times its mass. As for Proxima B, it is a super-Earth exoplanet, meaning it orbits a star outside our solar system. The first evidence of an exoplanet was discovered as early as 1917, though it attracted little interest at the time. The first confirmed exoplanet discovery came in 1992, shocking the scientific community. Another exoplanet, first identified in 1988, was officially confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets across 4,161 planetary systems. Of these, 896 systems contain multiple planets. The red dwarf star of Proxima B. Most of these exoplanets are found orbiting M-type, red dwarf, stars. But what is an M-type star? Red dwarfs are the smallest type of main sequence stars and are by far the most common in the Milky Way. However, they are incredibly dim, making them hard to detect with traditional methods. These tiny stars come in various categories based on their temperature and size. For example, M-dwarfs or M-type main sequence stars typically reach temperatures of around 3000 K. As for Proxima B, its mass is similar to 1.07 Earths, and it orbits its star in just 11.2 days, compared to Earth's 365.25-day orbit. This suggests that Proxima B's star is far smaller and dimmer than our Sun. Proxima Centauri, the star Proxima B orbits, has a total luminosity of just 1.6% that of the Sun. In the visible light spectrum, its brightness is reduced even further, emitting only 5 to 6% of the Sun's brightness. In fact, over 85% of its emitted energy is in the infrared radiation range. Proxima B was officially discovered in 2016. But with millions of stars, planets, and galaxies out there, why is this one so important? There are several reasons why astronomers are so fascinated by Proxima B. 1. It is the closest known exoplanet to Earth. 2. At just 4.2 light-years away, it is relatively close on a cosmic scale, even though, for Earthlings, that distance is still vast. Why is Proxima B so important? With a seemingly endless number of stars, planets, and galaxies in the universe, why does Proxima B stand out? There are a few key reasons. 1. Proximity. Proxima B is the closest known exoplanet to our Sun. At 4.2 light-years away, it is relatively near compared to other exoplanets. 2. Potential habitability. It lies within the habitable zone of its star, meaning conditions could exist for liquid water and possibly even life. 3. Red dwarf host star. Proxima Centauri is a red dwarf, a type of star that burns cooler and dimmer than our Sun. While red dwarfs are common, their habitability potential remains a major scientific question. Given these factors, Proxima B has become a top candidate in the search for extraterrestrial life. However, there are significant challenges. Red dwarfs often experience violent stellar flares, which could make Proxima B's surface hostile to life. The planet's tidal locking also means that one side is in perpetual daylight, while the other is in eternal darkness, a condition that could lead to extreme temperature variations. A new clue: artificial light on Proxima B? One of the most groundbreaking possibilities that scientists have explored is the detection of artificial light on Proxima B. This concept stems from the idea that if an intelligent civilization exists there, they may have developed lighting systems that could be visible from Earth. In 2024, the James Webb Space Telescope, JWST, was used to scan Proxima B for unusual light emissions. If a civilization on the planet uses nighttime illumination, the light spectrum might appear different from natural starlight. The discovery of artificial light would be historic, the first potential evidence of extraterrestrial technology. However, even if JWST detects something unusual, scientists will need to rule out natural explanations, such as volcanic activity, atmospheric phenomena, or reflective ice. If this artificial light hypothesis proves true, it could change everything we know about our place in the universe. What's next? The search for life beyond Earth is far from over. Future missions, such as the Extremely Large Telescope, ELT, and upcoming interstellar probes, may provide even more detailed insights into Proxima B and other exoplanets. In the meantime, scientists continue to study the atmospheres, climates, and potential biosignatures of distant worlds. Proxima B remains one of the most intriguing targets, offering a glimpse into the possibilities of life beyond our solar system. Whether we find intelligent civilizations or just strange, barren landscapes, the search itself is shaping the future of astronomy, technology, and human exploration. A straightforward blip following why Proxima B, our closest known star, is currently at the top of the list of priorities. It is a member of the triple star system known as Alpha Centauri. Despite Proxima's radiance being unimaginably low, the system itself appears as one of the brightest celestial objects in the evening sky, just behind two additional stars, Sirius and Canopus. Anyway, the most beguiling thing about Proxima Centauri B is that it could truly be habitable, as it falls within the habitable zone. The possible results of this discovery are profound. The people who study the star never stop, and as a result, space experts have taken over the investigation of its profundities and limitations. This is where the James Webb Space Telescope, JWST, comes in. The JWST's four most important objectives are: 1. To look for light from the primary stars and worlds that formed in the universe following the Big Bang. 2. To focus on the universe's arrangement and development. 3. To understand star and planet formation. 4. To explore planetary systems and the origins of life. As the JWST continues its evaluation, we get closer to understanding exoplanets like Proxima B. The highest priority among these missions is the search for extraterrestrial life. So, one might ask, why does this matter? Taking into account that humanity has always been a species driven by curiosity, exploration is inevitable. It makes sense that we continuously seek out the unknown. This is why missions like SETI, Search for Extraterrestrial Intelligence, exist. Imagine, on a massive scale, that the universe is an immense, intricate puzzle. We are required to keep an eye out for specific signals, electromagnetic sounds made by advanced civilizations, developments beyond anything we can currently imagine. SETI is essentially the world's highest-stakes game of hide-and-seek, with our planet acting as the searcher while the vast universe remains filled with hidden possibilities. In this field, specialists act like advanced Sherlocks, tuning into radio waves and searching for that enigmatic "we are not alone" signal. This enormous search began in the 1960s when Frank Drake, an exceptional astrophysicist, was one of the first to recognize radio signals from the stars. It was a paramount moment. However, no extraterrestrial visitors showed up at his doorstep. Now, as you might have figured out, searching for something massive requires perseverance, often spanning decades. At times, only a few tantalizing signals emerge, never conclusive, yet never fully dismissible. Despite the challenges, interest in exoplanets like Proxima B continues to grow, particularly as the James Webb Space Telescope expands our understanding of distant worlds. Will we accidentally stumble upon real evidence of extraterrestrial life? Or will we encounter unsettling signals that raise more questions than answers? The discovery of light from distant exoplanets like Proxima B could mark the next chapter in humanity's timeless fascination with the cosmos. It's a place where curiosity and technological advancement merge into one grand, exhilarating space story. So, let's keep searching, hoping to find confirmation that we are not truly alone. If we do detect light or signals from Proxima B, it may be an extraordinary step toward answering one of humanity's greatest questions: are we alone in the universe? As the James Webb Space Telescope continues its observations, its findings will undoubtedly spark more discussions, investigations, and possibly even new challenges to our fundamental understanding of life, intelligence, and the very nature of the universe itself. The ramifications of such discoveries go far beyond mere curiosity. They have the potential to reshape our scientific and philosophical frameworks. For instance, if we were to verify that Proxima B or another exoplanet harbors some form of life, it would force us to reconsider our place in the universe. Would extraterrestrial life evolve in ways similar to our own? Or would it present something entirely new? Would its development follow transformative pathways akin to our own, or would it challenge everything we know about biology and consciousness? Even without direct evidence, the mere possibility of detecting artificial signals or lights from far-off worlds would have profound implications. It would suggest that intelligent civilizations exist, beings capable, at least theoretically, of manipulating their environments in ways that make them detectable from across the cosmos. This would confirm that intelligent life is not an anomaly, but perhaps a widespread consequence of specific conditions within the universe. Nevertheless, it's essential to remain grounded and cautious. While the potential for discovering alien life is exhilarating, it also raises critical questions. How will we respond to confirmation of extraterrestrial life? Would we treat such a discovery with curiosity and scientific rigor? Or would it provoke panic, fear, or even political conflicts? History has shown that humanity's reactions to groundbreaking revelations, especially those that challenge deeply held beliefs, can be unpredictable. We must also consider the ethical implications of our curiosity. If we do find evidence of life, especially intelligent life, what responsibilities do we bear as stewards of our own planet? Moral considerations should guide our interactions with any form of extraterrestrial life, whether advanced or microbial. These are not simple questions to answer, and they will likely remain central to the conversation as we continue to explore the universe. If humanity were to detect an unambiguous sign of alien intelligence, whether through radio signals, infrared signatures, or even an interstellar artifact, it would mark a turning point in our civilization. The implications would be profound, touching every aspect of human life. 1. Scientific paradigm shift. The discovery of extraterrestrial intelligence would redefine our understanding of biology, evolution, and the very conditions that make life possible. It could challenge the assumption that life on Earth is unique or that intelligence is an evolutionary anomaly. Furthermore, it might provide clues about the longevity of civilizations. Are we looking at a society millions of years ahead of us, or one that just emerged? 2. Philosophical and religious repercussions. Different cultures and belief systems have long speculated about life beyond Earth. A confirmed discovery could either validate some worldviews or force reinterpretation of long-standing religious and philosophical doctrines. Would humanity's place in the cosmos be diminished, or would we feel more connected to a greater universal whole? 3. Political and societal impact. The response to alien contact, whether direct or indirect, would likely vary between governments and societies. Would nations collaborate in studying this discovery, or would it spark competition and secrecy? Would new policies emerge regarding how to interact with an alien intelligence, especially if it is more advanced than us? 4. The technological and ethical dilemma. If an extraterrestrial civilization is capable of transmitting signals across interstellar distances, it likely possesses technology far beyond our comprehension. Should we attempt to communicate back, knowing that we are revealing our existence to potentially superior beings? This is where the SETI versus METI, messaging to extraterrestrial intelligence, debate intensifies. Some argue that actively sending messages into space is dangerous, as we cannot predict how an alien civilization might react. Others believe that remaining silent is futile since an advanced species would already be aware of our presence. 5. The future of space exploration. If life, especially intelligent life, is found elsewhere, would it push humanity to accelerate interstellar exploration? Would we finally commit to long-term missions beyond our solar system, investing in technologies like nuclear propulsion, antimatter drives, or even theoretical concepts like the Alcubierre warp drive? The psychological effect on humanity. The realization that we are not alone in the universe could either unite humanity or divide it. Some might see it as confirmation of hope, that life finds a way in even the harshest cosmic environments. Others might fear the unknown, worrying about potential threats or our place in a vast, indifferent universe. Would humanity embrace this discovery with optimism, seeing it as an opportunity to learn from civilizations that have overcome the challenges we currently face? Or would paranoia and fear dominate, leading to a new era of cosmic caution? The next steps. As the James Webb Space Telescope, JWST, and future observatories like the Nancy Grace Roman Space Telescope and the European Extremely Large Telescope, ELT, continue to explore the skies, we may get closer to answering these questions. The data collected will not only help us analyze exoplanets like Proxima B, but also search for biosignatures, chemical markers that indicate the presence of life. Meanwhile, ambitious projects like Breakthrough Starshot aim to send tiny, high-speed probes toward Alpha Centauri, potentially giving us a close-up look at Proxima B within the next few decades. If life is there, even in microbial form, it would be one of the most significant discoveries in human history. The ultimate question: are we ready? Humanity has always dreamed of first contact, but are we truly prepared for what comes next? Whether we find simple microbes on an exoplanet or detect an intelligent signal from deep space, the discovery would be both exhilarating and deeply humbling. It is a reminder that the universe is vast and filled with mysteries waiting to be uncovered. As we stand on the edge of discovery, gazing into the cosmic abyss, we must ask ourselves,